So welcome to this lesson on Rook Polynomials Part 3. Here you learn the product formula and how to apply it in calculating Rook Polynomials. Also learn a formula to find arrangements with forbidden positions and how to apply Rook Polynomials in this case. So here we go. Suppose a board C is made up of two parts C1 and C2, where C1 and C2 have no squares in the same row or column of C. Then C1, C2 are called disjoint subboards of C, and the Rook polynomial RCX is RC1x multiplied by RC2x. This is the product formula. So coming to a question, find the Rook polynomial for this numbered part. So we have two disjoint subboards here, 1, 2, 3, 4 and 5, 6, 7, 8, 9, 10, 11. So we first take C1. Here RCX, we know the formula, we have already learned it in the earlier parts. RCX is 1 plus R1x plus R2x squared. R1 is 4, R2 is 2, since there are number of ways in which two rooks can be placed, so that no two of them capture each other is 2. That is 1, 4 or 2, 3. As a recapitulation, two rooks capture each other if they are in the same row or column. So RC1x is 1 plus 4x plus 2x squared. What about C2? Here R1 is 7. There are 7 blocks, and the number of rows in ways in which two rooks can be arranged so that no two of them capture each other is 10. You have 5, 8, 5, 9, then 5, 11, 6, 7, 6, 9, 6, 10, 7, 9, 7, 11, 8, 9 and 8, 10. And R3 is 2, that is number of ways in which 3 rooks can be arranged so that they don't capture each other is 2. You have 5, 8, 9 and 6, 7, 11. And the rest of them R4, R5, R6, R7, what are they? They are all 0. So RC2x will be 1 plus 7x plus 10x squared plus 2x cubed. We use this formula, 1 plus R1x plus R2x squared and so on. And multiplying both RCX is RC1x into RC2x, we get it as RC1x, what is that? 1 plus 4x squared, 4x plus 2x squared, and RC2x is 1 plus 7x plus 10x squared plus 2x cubed. So this is your answer. Coming to the next question, find the Rook polynomial for the numbered squares. So here your squares are 1, 2, 3 and 4, 5, 6, 7. So as usual, we calculate them separately. What happens for C1? What is R1? 3. And R2 is 1. Only one way of arranging two squares, that is 1, 3. R3 subsequent Rook polynomials are all 0. So RC1x will be 1 plus 3x plus x squared. For C2, what is R1? It is 4. R2 is 3. You have 4, 6, 4, 7, 5, 7. R3, R4 are all 0. That is, why are they 0? Because number of ways in which you can arrange 3 or 4 Rook polynomials in which they don't capture each other is all 0. So RC2x will be 1 plus 4x plus 3x squared. And again coming to the formula, RCX is RC1x into RC2x. That is 1 plus 3x plus x squared into 1 plus 4x plus 3x squared, which is 1 plus 7x plus 16x squared plus 13x cubed plus 3x raised to 4. Now coming to the practical application of all this, why are we doing all this? So look at this problem. An apple, a banana, a mango and an orange are to be distributed to 4 boys B1, B2, B3, B4. The boys B1 and B2 do not wish to have an apple. The boy B3 does not want banana or mango, and B4 refuses orange. In how many ways can the distribution be made so that no boy is displeased? So these are the boys and these are apple, banana, mango, orange. So we have arranged it accordingly. B1 and B2 don't want apple, B3 don't want banana and mango, and B4 doesn't want orange. So we have the blocks here B1, C1, this is C1, C2 and C3. Again RC1x is 1 plus 2x, R1 is 2 here, RC2x is 1 plus 2x. RC3x, it is just 1 here, so it is 1 plus x. R1 is 1. So if you multiply all RCX will be they're all disjoint rc1x into rc2x into rc3x, that is 1 plus 2x the whole squared into 1 plus x. So when you multiply you get 1 plus 5x plus 8x squared plus 4x cubed. Now here comes the catch. Look at this formula which you should learn. Suppose m objects are to be arranged in n places where n greater than or equal to m. Suppose some objects cannot occupy certain places. The number of ways in which this can be done is given by n bar equal to s0 minus s1 plus s2 plus minus 1 raised to n sn. Where what are all these? Sn is n factorial, sk is n minus k factorial into rk. K taking values 1, 2 to n. And what is rk? Rk is the coefficient of x raised to k in the Rook polynomial where the squares represent the forbidden positions. Quite a lengthy formula but a good and useful one. So coming to this question, we have rcx is 1 plus 5x plus 8x squared plus 4x cubed. This is what we just calculated for the above problem. So what is r1? r1 is 5, r2 is 8 and r3 is 0. Now s0 is n factorial. What is n here? N is the number of places, so the number of boys, which are 4. So s0 is 4 factorial. S1 will be n minus k factorial, that is 4 minus 1, 3 factorial into r1, which is 6 into 5, 30. What will be s2? 4 minus 2 factorial into r2, that is 2 into 8, which is 16. And s3 is 4 minus 3 factorial into r3, that is 1 into 4, which is 4. So substituting in this formula, we get number of ways will be s0 minus s1 plus s2 minus s3. That will be 24 minus 30 plus 16 minus 4. So your answer is 6. So I hope this lesson on Rook polynomials was useful for you. Here you have learned the product formula and how to apply it in calculating Rook polynomials, and you have also learned formulas to find the arrangements with forbidden positions and how to apply Rook polynomials in this class. Thank you and happy learning.